Dear friends, welcome you to my video on Architecture of Expert System in Artificial Intelligence. First is knowledge base. At the heart of any expert system lies its knowledge base. This is where all the information, facts, and rules related to a specific domain are stored. You can think of it as a vast library filled with books containing the wisdom of human experts. The knowledge base is usually created through a collaboration of domain specialists and knowledge engineers, ensuring that the system has access to reliable and relevant information. The more comprehensive the knowledge base, the more effective the expert system will be in providing accurate and insightful solutions. At is the inference engine, often regarded as the brain of the expert system. This component processes the information stored in the knowledge base, applying logical rules to deduce conclusions or make recommendations. Imagine having a super smart friend who can sift through an overwhelming amount of data in seconds, identifying patterns and making decisions based on what they find. That's essentially what the inference engine does. It employs various techniques, like forward and backward chaining, to navigate through the knowledge base and arrive at conclusions. This dynamic interaction allows the expert system to adapt its responses based on the specific queries presented to it, making it feel more personalized and responsive to your needs. The user interface is where the magic meets you. It's the bridge that connects you with the expert system, allowing for seamless interaction. A well-designed user interface makes it easy for you to input your queries and receive answers in a clear and understandable way. Whether it's a simple text box for typing questions or a visual display showing recommendations, an intuitive user interface can significantly enhance your experience. Imagine a friendly chatbot or an interactive dashboard that guides you through complex decisions. This is what a good user interface achieves. By focusing on usability, expert systems can ensure that even users with minimal technical knowledge can access their powerful capabilities. Finally, we have the explanation facility, which serves as the expert system's teacher. When you receive an answer, it's crucial to understand the reasoning behind it, and that's exactly what this component provides. The explanation facility offers insights into how the inference engine arrived at a particular conclusion, essentially breaking down the decision-making process. This transparency not only builds your trust in the system but also helps you learn from the interaction. For example, if you're seeking financial advice, understanding why the system recommends a specific investment can empower you to make informed choices in the future. This component makes expert systems not just tools, but valuable learning aids in your journey toward knowledge and expertise. Knowledge representation is a crucial aspect of expert systems, as it dictates how information is stored, organized, and utilized to make decisions. In simple terms, it's about converting complex data into a format that the system can understand and use effectively. Imagine trying to solve a puzzle without knowing what the pieces look like. That's how expert systems would function without proper knowledge representation. It allows them to reason, learn, and apply knowledge in a way that mimics human expertise. There are several approaches to knowledge representation in expert systems, each with its unique advantages. Production rules. These are, if-then, statements that outline a specific action to be taken based on certain conditions. For example, if the patient has a fever, then consider a diagnosis of infection. Semantic networks. This method uses graphs to represent knowledge in a visual format, where nodes represent concepts and edges represent relationships between those concepts. It's like a map that helps the system navigate through its knowledge base. Frames are data structures that hold information about particular objects or concepts, similar to a database record. They can include attributes and values, making it easier to organize related information. Understanding these methods gives you insight into how expert systems can simulate human reasoning and problem solving. Each representation technique plays a critical role in enabling the system to draw conclusions and generate solutions from a vast pool of knowledge. As you can see, the way knowledge is represented is not just a technical detail, it's foundational to the expertise that these systems provide. At the core of every expert system lies the inference engine, often referred to as its brain. This powerful component is responsible for processing the knowledge provided by the system and applying it to draw conclusions or make decisions. You can think of the inference engine as a skilled detective, piecing together clues to solve a mystery. It takes input from the user and the knowledge base, then applies logical rules to generate outputs that are both relevant and useful. There are two primary methods for inference engine: forward chaining and backward chaining. In forward chaining, it starts with the available data and applies rules to infer new information until it achieves a goal. Conversely, Backward chaining begins with the goal and works backward to determine which data or rules must be satisfied for that goal to be achieved. Understanding these two approaches can help you appreciate the flexibility and adaptability of expert systems in problem solving. Forward chaining. This method is data-driven. It starts with known facts and applies inference rules to extract more data until a conclusion is reached. It's often used in situations where you have a lot of information and want to derive as much knowledge as possible. Backward chaining. This method is goal-driven. It begins with potential conclusions and works backward to find supporting data. It's particularly useful when you have a specific problem to solve or a decision to make and can ask whether certain conditions are true. The efficiency of an inference engine can significantly impact the performance of an expert system. A well-optimized engine can process complex queries quickly, allowing users to receive timely solutions. As you explore the architecture of expert systems, you'll notice that the inference engine often determines how effectively the system can operate.